Hey guys, today I'm going to be covering the energy formulas for potential and kinetic energy, but I'm also going to start with reviewing what we covered earlier this week about potential and kinetic energy, okay? So first we need to understand what work is, okay? But to understand work, you have to have a basis of what energy is. But work is the transfer of energy by applying a force over a certain distance. So if I use some energy to push a box across the floor 10 meters, that's work, okay? So the key point is the work energy theorem is that in terms of physics, work is always the outcome of the use of energy, all right? So make sure you understand that. And energy is a measurement of the ability to do that work. It's a quantitative measurement, which means it's a numbers-based measurement. So I'm going to be like, I used 10,000 joules of energy, and joules is the unit of energy we use for energy. All right, so it's the same as work. If I did 10 joules of work or 10 joules of energy, we're talking about the same thing there, kind of a little bit, okay? All right, so there's different types of energy. There's mechanical, electromagnetic, thermal, chemical, and nuclear. We talk about all of these in our class. Mechanical is just moving things and sound waves and stuff. Electromagnetic would be magnets, obviously, and microwaves. Thermal is using heat to make some energy. Chemical is much more chemistry-based, but it's you might remember it from biology, talking about ATP in biology, but it's where the energy is stored in bonds, and then the nucleus is like nuclear power breaking or splitting the nucleus. All right, so there's two different types of energy we're going to talk about. The first is potential energy, which is energy that's stored in an object's position, specifically above the ground, okay? So how far it is above the ground, we're going to get to that, but it's not moving. It has a lot of potential to move. Like if I put a tennis ball on the edge of my table, my desk, that's potential energy. Kinetic energy is what we're going to talk about next. I'm going to come back to that. That's the energy associated with movement, okay? So yesterday we learned about the formula to calculate potential energy, and it's a pretty straightforward formula. It's potential energy equals mass times the gravity, which is always the same on our planet, 9.8, times the height off the ground. So if you're given a question like this, what is the potential energy stored in a box if it has a mass of 100 kilograms and is stored on a shelf 2 meters above the ground? Just plug those numbers in. Right? So mass is 100 kilograms. Gravity is always the same on Earth. It's 9.8. And then above the ground is 2 meters. So here's the equation. Just take away the units. It makes it a lot easier to look at. Just don't worry about that right there. I don't know why I have that right there on here. There you go. So if I do a 100 times 9.8 times 2, it's going to give me 1,960. Just slap a J on the end of that, and that means 1,960 joules. And that is your answer there, okay? So it's really that simple formula, just plugging things in from the equation. Then you have kinetic energy, and this describes movement, all right? So we're looking at the movement of the energy. The formula here is kinetic energy equals half the mass times the velocity squared. And we talked about velocity last unit. It's just the speed, like meters per second, something's moving. So 1/2 times the mass times velocity squared, okay? So if I had to consider this, what is the kinetic energy to move 1,000 kilogram car forward in a velocity of 18 meters per second? So I'm going to do 1/2 right down here. So 1/2 times 5 times 1,000. Again, just drop the units. 1/2 times 1,000 times 18 squared. So 1/2 times 1,000 is 500. 18 squared is 324. Just multiply those together. Gives you 162,000. Just slap a J on the end of it, and there's your answer. Okay? You will also be asked to get things alone by themselves, right? So you might be given the potential energy. You might be given the height or the mass, and you got to find the other thing. Okay? So that's something you might have to do as well. This one here is just a standardized one. But you might get one like this, okay? So if a flower pot is at a rest on a windowsill at 4.5 meters above the ground, what is the mass if the potential energy is 34? So 34 goes over here. X is right here for my kilograms, because I don't know what I'm trying to find that. Times gravity and height. So what I can do is do gravity and height. These are going to equal 44.1, right? Then divide both sides by 44.1. That will give me X by itself. And so it's going to end up being 34 divided by 44.1 equals X. It's going to be 0.77. So that's how you would basic algebra stuff, but I will work with you guys in class to help you guys figure those out, or to get used to doing that. But it's very similar to last unit. Just finding the variable. In this case, was mass. And how do you get mass by it? How do you get the x here by itself? You divide both sides by what you have, and that'll give you the answer you need, okay? This one here is one using kinetic energy, trying to find the mass of it as well. So you're going to do half times 12 in this case, or half times 12 squared. So it'll be 72 divided both sides by. But I'm going to walk you through this today and help you guys out in class in our one-on-one times. But if you have any questions for this, please email me. We can set up a private Zoom session if needed, or we can just talk about it after class, okay? But I will see you guys today.